So welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing in our Cloud Provider Business Unit at VMware. And today I'm joined again by Stefan and Gerrit. Guys, thanks for joining. Stefan, quick introduction from yourself.
Yes, thanks a lot, Guy. My name is Stefan Berner. I'm lead solution architect in the BCPP environment, focusing on modern applications.
Thanks, Stefan. And Gerrit?
Yeah, thanks, Guy. Gerrit Lehr, Cloud Solution Strategist in the worldwide multi-cloud strategy and architecture team, focusing also on Tanzu, but also on anything else that's cloud provider and multi-cloud related.
Excellent. Thanks, guys. So today is the second in a mini-series that we're doing around Tanzu, and hence why we have you guys on, the application modernization experts. In the last session, we covered some of the basics around Tanzu. The packaging, what was in the versions, what worked with what, and really making it hopefully a bit easier for a service provider to identify where they should start with Tanzu. Today we're going to dive a little bit more into Tkgs. So let's start by just rewinding a little bit. Can one of you pick up the question I'm going to ask? If you're looking at Tanzu, you've got Tkgs as an option, Tkgm. As a Tanzu basic, it's inclusive in your flex core to use either. What are they? Just let's recap. What are the main differences between them?
Yeah, so maybe I'll start on that, and Stefan, you can join me on that. So first of all, Tkgs is the TKG service that is embedded as part of vSphere 7 with Tanzu. Right? Meaning that it only runs on vSphere 7 and it's tightly integrated with that platform from a deployment, but also from an operations perspective, right? So this makes it easier to stand up and lifecycle manage a Kubernetes cluster if you're a vSphere admin and you're familiar with that tool and that platform, right? Mm-hmm. Tkgm, on the other hand, which stands for multi-cloud, can basically run on any hypervisor, whether it's an older version of vSphere or really any public cloud, including native virtual machine services from Azure, and so on. And that then requires a different way of deploying and lifecycle managing it, and is not really tightly bound to vSphere, right?
Okay, but technically they both contain very similar capabilities. Or is there a difference between the capabilities, Stefan, for you?
Yes, from a capability perspective, they are quite similar. And I will touch in a few minutes on the network architecture. But because of the network architecture, I will explain later. The Tkgs solution is more suitable for a single tenant solution. So as soon as you dedicate a whole vSphere cluster to a customer, or as soon as you don't have a shared environment, Tkgs is more suitable than Tkgm because of the network architecture.
Yeah, and as Gerrit says, right, the operational capabilities and maintenance capabilities. Okay, so let's dive into that. So today is all about Tkgs. We're going to kind of start on that single tenant environment. Let's understand what are some of the kind of the outcomes that you would get with Tkgs in a single tenant environment.
So here we go. Okay. As Gerrit already mentioned, the basis for Tkgs is the vSphere environment, is the ESX environment. We already mentioned on top of the environment, we will have vCenter server, we will have NSXT in this environment, and we have Cloud Director, maybe. So we have a traditional management environment. So what happens if we enable the so-called workload management? So in vCenter server, you have to go to workload management and enable it. And then vCenter server will be capable of acting as Kubernetes. So what technically happens when you click on enable workload management, vSphere and vCenter will deploy 3 supervisor nodes, so the so-called Supervisor Engine. And the Supervisor Engine, because if you look at the picture, it might look like the supervisors are running within vCloud Director or on top, but it's just running in vSphere. And these are 3 virtual machines containing Kubernetes. And with enabling the workload management, we enable vSphere to act as a Kubernetes cluster. So the supervisor engines will act as master nodes and the ESX server can act as worker nodes. And now let's have a look. So within Kubernetes, and I will just start and explain some Kubernetes concepts, because within Kubernetes, you have the concepts of pod networks and service networks. So pod networks are the networks where at the end of the day, the workload will be published. So whenever you create a container, it will automatically out of the box being connected to the pod network. Because within Kubernetes, you could have some services as well, because it's one characteristics of microservices is that you have more than one container. For example, if you look at some etcd database, for example, so a key value store, you will have not only one container, but you will have several containers. And therefore, we have a service network. So within a service, we will create some kind of load balance service where more than one container is connected to, or deployment, whatever you create. And it's an internal network where the services are Kubernetes internally known. So how does it look? In a vSphere pod, and you can create this pod, this deployment within Tkgs just with using kubectl. So I haven't added this, but it's just to create a pod deployment. So it's called vSphere pod as soon as the pod is running directly on an ESX server. And you just have to execute the kubectl run. So it's the common interfaces a developer knows. And this, in my opinion, and it's a very important design concept of the whole Tanzu portfolio, is that you give your persons, your personas, the tools they are used to. So what never ever would work if you would force a developer to use vCenter server to create a container. But with Tkgs, we give the developers their well-known tool called kubectl or all the tools around it. And we have for the vSphere administrators the vCenter server so that they can manage the Kubernetes environments with their tools as well. And in this example, we created a pod, a deployment directly running on an ESX server. So I mentioned that the ESX server can act as a worker node. And in this case, they are directly executed on the ESX server. We have a second possibility to deploy Kubernetes workloads on Tkgs. This is a so-called Tkgs cluster. In a Tkgs cluster, we deploy in a virtual machine-like context, we deploy worker and master nodes. So we can create a full-blown Kubernetes cluster within this TKG context. And the TKG cluster itself will be connected to the pod and to the service network, and all the components will be available via the service network.
Hey, Stefan, is that more like just an encapsulation then of what would be a vSphere pod deployment, just putting it into an actual VM and putting all of the components it needs in that VM?
Not really. The TKG cluster is really a full-blown Kubernetes cluster with its own API endpoint, with its own management endpoint. It's a full-blown Kubernetes cluster that is created in a TKG context. Whereas in a vSphere pod is just the Kubernetes entity deployed. So with a vSphere pod or in a vSphere environment, you can create pods, deployments, whatever Kubernetes can create, you can create it in a vSphere context. And these entities are created within the ESX server.
Yeah, so they don't require a VM, that overhead of a VM to run. Yeah, okay.
Yeah, just to reiterate what we discussed on the last session as well, right? So both are parts of vSphere 7 with Tanzu. Both are totally capable of running Kubernetes pods, right? But there are still some minor differences between running TKG service in vSphere 7 or running vSphere pods directly on ESXi hosts, right? And that's mainly that, the Tkgs cluster is fully upstream conformant. So whatever runs on the native Kubernetes distribution that's out there in the open source world will run the same way in Tkgs clusters. Whereas with vSphere pods, you'll have some advantages in regards to security, isolation, and performance, but with some trade-offs that, certain features like, escalated privileges, for example, will not work in that particular pod, right?
Yeah, that's right.
That's right. And the developers really like it, because they can now create Kubernetes clusters like they would create deployments in pods, for example. If you as a service provider open the Supervisor Engine to a developer, he can create a Kubernetes cluster as he would create other Kubernetes entities as well. Cool. So let's dive a little bit more into the internet, into the network access, because all applications you create don't have any value if you don't expose them. And within Kubernetes, so this is a Kubernetes context as well. In the Kubernetes context, we have two networks. So it's the egress network. Egress network is an outbound network. And I just showed for the egress network, for the TKG cluster, for the TKG service cluster, the inbound traffic for the vSphere pod. It's just an example. That doesn't mean that we don't have inbound traffic with the TKGS cluster. It's just for graphical representative so that you can see it easier. So egress network, as I mentioned, is an outbound network. So basically we create a netting rule, an SNet rule, to enable outbound traffic to the internet. So there's not really something about it. What's worth to note, and this applies for the egress as well as the ingress network, is that the egress and the ingress network are shared between vSphere cluster. So the vSphere with Tanzu is enabled on a vSphere cluster, and all Kubernetes workloads, all Kubernetes clusters, everything created within this cluster shares an ingress and egress network. And this is the main reason why we recommend to use TKGS in case of a single tenant solution. As long as it's okay for your customers that they are on the same layer 2 network, then TKGS is a good solution. Let's have a look how the inbound traffic would look like. So the ingress network, so the inbound network, is typically connected via a firewall. So normally service provider has a perimeter firewall in between, but the ingress network is directly connected to the network. And within TKGS, we create a load balancer, so an NSXT load balancer, an NSXT firewall. You even can have a web application firewall in front of your application. And this NSXT firewall, load balancer, web application firewall is used to load balance the traffic to the pods, to the deployment, to the TKG clusters.
That's probably one important thing to mention, right? NSXT in the service provider world in the advanced edition is a hard requirement for TKGS and vSphere 7 with Tanzu. And that's a difference comparing to Tkgm as well, right?
Yeah, it's NSXT full stop across the board, right?
Yeah.
Okay, so I think I understand that. So just rewinding 2 seconds. So that egress network, or was it, sorry, yeah, egress network was shared, but at a layer 3 segregated between the clusters. Was that right, Stefan?
Yes, the vCloud Director can segregate the customers with a distributed firewall with microsegmentation. That's absolutely possible. And therefore, I recommend you to watch the Feature Friday session number 62. There it is explained more in detail how the separation and the networking, routing, and all so on works.
Yeah, so just once again, though, if I was looking at a multi-tenant environment, really the recommendation is to look at Tkgm and not Tkgs. Yeah, okay. So if I had a standalone vSphere offering, hosted vSphere offering maybe for a customer, I would then be very easily able to implement TKG, whether that's Tkgs clusters or vSphere with Tanzu pods. That would be equally a suitable solution for single tenant customers.
Absolutely.
Okay. And we spoke yesterday about some of the advantages around the vSphere pods versus the disadvantages, speeds and some of the capabilities there are why you would not use TKGS and use just the vSphere with Tanzu, but then like Garrett was saying, right, there's some compromise with security. So just if you're looking at this, understand more about what your customer is after before you make that decision. And NSXT is a mandatory requirement. And we're doing load balancing here to the actual pod, and that's part of the NSXT, that's part of the AVI capability. Is that right, Stefan? It's come from NSXT Advanced?
No, in the context of TKGS, we are using the NSXT load balancing.
Okay, so the next level up from that, if you wanted to do container ingress load balancing and container ingress firewalling, you could look at the NSX Advanced Load Balancer, which is the old AVI product.
Yes, and there we have some integrations into Tkgm as well. So we have plugins for Tkgm, we have plugins for Kubernetes. So whatever solution you are choosing, it can be integrated into AVI.
So from a productization standpoint, Garrett, what do you see service providers, or how do you see service providers offering these services with TKGS? What's been your experience so far?
Yeah, so as I mentioned, one of the main differences between Tkgm and TKGS is that you have a hard requirement on NSXT, especially when you're using VCD, right? And in the first, discussions that you have with partners, you might encounter that this might makes it look a bit more expensive compared to, having a Kubernetes distribution which does not require the advanced edition of NSXT. But when you turn that around into what are you actually selling and what are your customers actually getting from this Kubernetes as a service that partners are building from TKGS plus NSXT, you'll actually find that there are more capabilities that you can then monetize based on the NSXT requirement. So what this means is, with TKG itself, you could compete against something like Azure Kubernetes Service or Amazon Elastic Kubernetes Service. But if you look at the complete picture, you'll always need load balancing, firewalling, and so on anyways. So in AKS and EKS, these are the equivalent hyperscale services like Azure Firewall or, Amazon Elastic load balancers and so on. And since, TKG S already includes the requirement for NSXT Advanced, you already have all those capabilities, and our partners will then actually monetize and sell those to their customers, just like they would need to purchase this from a hyperscaler. So they're already paying for the whole stack to offer as many firewalls and load balancers as they wish to their customers, but can then in return monetize that as an additional chargeable service.
And how would NSXT in this, we're talking about a single tenant environment with TKGS, how would NSXT be charged then to the service provider?
Yeah, so that's based on the similar model as the Flex Core VRAM that we have, right? So depending on the NSX version or edition, in this case, this is NSXT Advanced that we need, we would charge the partner based on the amount of VRAM or the amount of VRAM used by virtual machines that are using the NSXT features, right? So in this context, this would be the worker and master nodes that build the Tkgs cluster. And for the amount of VRAM used by these VMs, we would charge the additional 3 points for NSXT Advanced capabilities.
So if we're looking at an environment where we had multiple customers, a shared vCenter environment, for example, and I want to start offering Kubernetes services on my shared vCenter environment, I'm okay with layer 2 being shared, layer 3's, where we need to get tenant specific. I could then actually implement NSXT, number one. So vCenter, NSXT, move to that model where I can now provide microsegmentation, additional services. I can upsell my existing vSphere consumers. I can then offer TKGS, and at the VM level, I can provide the ingress and egress, or the ingress routing to that VM. I can then protect that with individual firewalls to that VM and load balancers to that VM and monetize those as well discreetly and only pay for what I consume.
Exactly, and that's one of the advantages of the VSVP program and the capabilities that Usage Meter brings to pick up what partners are actually using, right? So this doesn't mean that you have to license the entire environment or even the entire cluster with NSXT Advanced. Usage Meter will pick up which of those VMs, in this case, the TKGS worker and master nodes, are using advanced features and only charge you for those. So the rest can remain on NSXT base or professional or whatever it is that's suitable for your customers.
Yeah, it's interesting. Just like on another note, I mean, when you go to an existing vSphere install base, shared vCenter environment, and you say, right, NSXT is what you need, the typical is like, well, that's an extra cost, and I can't get any more money from my existing clients. But what you can do is start like phasing out your physical firewalls, phasing out your physical load balancers, replacing them with software-defined load balancing and firewalling. Which is going to save you, the provider, money from renewing that licensing and that hardware, and also the energy associated with it. Improve your carbon footprint. That's always a good one.
Yeah.
and then also then ready yourself for that containerized service, which you could then provide.
Yeah, and on a financial perspective, this also helps with optimizing your cash flows and right sizing the environment and optimizing the investments that you're making, right? So if you're buying a large perimeter firewall or load balancing appliance, that'll usually be sized for the extreme load spikes that you might see in your environment, right? Whereas with the software-defined approach of NSXT, this will scale based on what's actually being consumed because it's virtual, right? And then on the cash flow portion, I mean, you're not really investing in this huge perimeter box up front, which is going to have a huge cash outflow. You're being charged in a granular pay as you go monthly basis, depending on what you're actually consuming, which is then nicer on your cash flow, right?
Yeah, absolutely.
It's an OpEx model for the provider there.
And I'm
involved. I think. Sorry, go on, Stefan.
Involved at the moment in a project where a service provider is replacing their hardware firewall. And one comments, and I heard it the first time, the customer told us, wow, is it cheap compared to a hardware firewall?
Cheap, and they still get good capacity and good throughput. And it's a question of I've always think about trying to change someone's mindset. Tenants sometimes expect physical firewalls, physical load balancers, because that's what they've had in their environments. Whereas actually, the load balancers aren't going to be as good. Let's face it; they're not going to be like the huge functionality that you get with a full-blown hardware appliance. But they're going to be good enough for like 90% of the tasks that you'll find that actually people really use load balancers for. And the same with the firewalls. Okay, so that kind of covers off. And what I was trying to really kind of communicate to our providers, hopefully listening, is that if you've got a shared vCenter environment, there's options here, and certainly moving to and have NSXT included in your environment will give you benefits. There is additional cost option, obviously, to your VCPP cost, which Gerrit laid out there, but you can look at offsetting that with removal of physical and gradually phasing out those licenses. You can then also drive net new revenue with the Tkgs Kubernetes Cluster services. And Gerrit, I just want to zoom back. Before this call, we were just chatting and you mentioned something about serverless. Do you want to sort of zoom into that as well as another potential view?
Yeah, so one potential model that partners could also build on TKGS is, building dedicated or even shared vSphere with vSphere 7 with Tanzu clusters and using vSphere pods to offer, this in a very managed way, where then, customers would only, have to run or schedule their pods on this platform, which is fully managed, so they wouldn't get a lot of access to the underlying infrastructure. But then, on the other hand, only get charged for scheduling and running of those container pods compared to, being charged for an entire Kubernetes cluster, which may not be 100% occupied or utilized, right? So this is something that requires some managed services on top, but it's potentially something that brings our partners closer to offering more of a serverless container model.
Got it. And with that could work, I suppose, in a hybrid environment where you'd have TKGS and a vSphere Tanzu pod, because you could then take those runtimes from one environment to the other if you needed to for capacity reasons, perhaps.
Yeah.
Okay, that's a good offering as well. Okay, anything else on TKGS? I mean, we discussed and touched on some of the aspects of TKGS with VMware Cloud Director, but for all intents and purposes going forward, the answer for Cloud Director is Tkgm, and that's where our cloud providers are now, looking, and that's where we're investing our R&D and kind of software approach with VCD and Tkgm. But if you do have TKGS, then there is the kind of network isolation that is automated by VCD, and as Stefan said, right, that was discussed in episode 62 on Feature Fridays with container service extension. So we're not saying you can't do TKGS with VCD. What we're saying is there's some aspects of the networking which VCD has had to kind of work around to, I don't want to say correct, but the word I'm looking for is perhaps just to fill some functionality that needed to be filled. But primarily, the route to market for TKGS should be single tenant or shared vCenter infrastructure if the tenants are happy with sharing a layer 2. And what risk would you say, Stefan, from a layer 2 perspective, is that something that I don't expect is something that is typically shared amongst tenants?
No, typically you don't share it. But as you mentioned, in Cloud Director, you can use TKGS as well. And in combination with Cloud Director, we are automatically bringing in place some microsegmentation, layer 2 firewalling, so that these segments are separated and securely separated.
Right. So in that case, then, if you have a shared environment, again, VCD is probably the best answer for your shared environment from a security perspective. Yeah. Okay, great.
VCD is the magic multi-tenant glue for all our products.
Yeah, the magic multi-tenancy. Any final thoughts on TKGS?
If you would like, I can show you TKGS in action.
Let's have a quick look.
Yeah. Give me a second.
Never say no to a demo.
So here we go. And I will very briefly show how it looks like in vCenter Server, because we told you that Kubernetes is integrated into vCenter Server. So let's have a look. And I mentioned already the workload management. So let's have a look what we configured here already. So you can see out of vCenter some Kubernetes terms like namespaces. Namespaces are quite comparable to resource pools if you are not that familiar with Kubernetes. But within a vCenter server here, you see some Kubernetes entities already. And as I mentioned, we enable the workload management on a vSphere cluster. So here you could see one cluster with 4 hosts. We created 3 namespaces within this cluster, and it's in a running state. So let's look a little bit more into how it looks like from a Kubernetes perspective. So we have here some resource pool for namespaces, and you will already notice here some funny symbols. So this means that here we are using Kubernetes entities. And let's have a look where we have some Kubernetes running. And here I found already a Tkgs cluster running. So you see here nowhere and the typical Cloud Director UUID appended. And if we look into it, we see a Kubernetes cluster. Here you can see it's a control plane node and a worker node. And I get often the question, is a Tkgs cluster, is it a virtual machine? Is it a Kubernetes entity? It's somewhere in between. So if we have a look into and try to power it on, power it off, so you will notice that you cannot act with this Kubernetes entity as a virtual machine. And some useful fact to know is that we define the TKG cluster as we would define a deployment. So for those who know Kubernetes more well, we are using something like a replica set, and we define a desired state. So we need one control plane node and one worker node. And as soon as one of the worker or master nodes fails, the controller will take care of that the desired number of Kubernetes worker and master nodes are running. Mm-hmm. What else you could see is here is the Supervisor Engine. So as I promised, we have 3 virtual machines where the control plane, where the Kubernetes master nodes are running.
Just one thing to add, because it came up in a recent conversation with a partner, is that supervisor control plane nodes, the supervisor cluster, that is only deployed once per vSphere cluster. It's not per tenant, even in a multi-tenant environment with VCD on top, right? So this would be shared amongst tenants, which is important in terms of resource overhead, right?
Yeah. And as Stefan said last time, right, they're pretty small VMs.
Yeah.
But just to go back to that vSphere view, that cluster you got there, that sandbox environment, that is a VCD UUID in the nowhere cluster.
Yes.
This is a Tkgs cluster under VCD control.
Yeah. Yes.
Correct. Yeah. Okay.
Control of VCD, and here you see it works, and therefore I mentioned it's comparable to resource pools. So vCloud Director creates for whatever customer you create, it creates an own namespace. So on a Kubernetes perspective, the tenants are separated via namespaces already. And if we look at the namespaces, it works similar as a resource pool. So I have just to move the control plane of Zoom. So here you could see we can set a CPU limit, we can set a memory limit, we can set a storage limit, we can give storage quotas, we can give permissions. So it works very similar to resource pools already. And it's really quite integrated into vCenter Server. And now
those permissions you got there, sorry, just back to those. Are they're not where are those permissions, and what is the kind of repository for those users for that permission structure?
So in this permission structure, you are using the vCenter permissions.
Oh, okay, right.
And you can have a look into more details of the Kubernetes as well. So here you could see I mentioned services. A vSphere admin can have a look at the services, can view the definition of any Kubernetes entity out of vCenter Server without knowing Kubernetes very well and without the need of knowing. So they could look into storage as well. So really a nice view into the Kubernetes internals without having to learn Kubernetes in detail.
Yeah, and just to comment on that aspect from a financial and TCO perspective, right? So we've done some analysis of what does it actually mean to run Tkgs on vSphere, including VCD, from a total cost of ownership perspective versus I'm running the free open source Kubernetes version. And that was back in the days when Tanzu Basic wasn't included free of charge, right? It actually turned out that at scale, due to the reduced labor efforts that you have for setting this up, for training your people in Kubernetes, for keeping this up and running, Tkgs should definitely come out cheaper than the open source alternative, right? Not from a licensing perspective, obviously, but from a operations and staff point of view and from total cost of ownership. So that's really important to consider when you're building these TCO models and making a decision for your VCP-based platforms.
And then let's have a quick look into Cloud Director, and I will keep it very brief because otherwise we will discuss in 2 hours still what's going on here. If you look into Cloud Director, you see immediately that whenever you add a provider VDC, a vCenter server with Kubernetes enabled, you see that vCloud Director automatically recognizes that Kubernetes is enabled on this VMware cluster. And within the org VDC, you can define, or you will define like an allocation policy. You will define the Kubernetes policy as well. So here you could define, for example, we have defined a production environment with 10 gigahertz of limits, and I have created special for today a Feature Friday policy with less resources. And here you define what your customers can utilize and what they can't utilize. And then let's have a look how it.
That's really nice, because that's really kind of differentiated, being able to do that like a multi-tenancy level, to be able to provide those resource constraints and allocation models is something you wouldn't get normally. So I think that's really a nice offering.
Yeah, absolutely. And let's have a look how it looks from a customer perspective. So from a customer perspective, creating a Kubernetes cluster is really easy. So we have to choose which deployment methods, so Tkgs, Tkgm we want to use. We define a name, so let's call it Feature Friday.
That's a good point. Can you have Tkgs and Tkgm enabled in the same cluster?
Absolutely.
Okay.
It would be just another tile here. Where you
that's what I thought.
The following dialogues are 99% the same. So it looks very, very similar. And therefore I will just show it with Tkgs. So you have to pick and choose the provider as a virtual data center. Now we can choose the policy. So the defined policy, if it's a QA, production, or sandbox environment, you can define which Kubernetes version you would like to use. And you can see it's a bunch of Kubernetes versions from a very old 1.16 up to a 1.20 version, quite a recent version. And then you define your Kubernetes cluster, how many master, how many worker nodes you would like to have. So one control plane node, one worker node, and you could define the size of your nodes as well. And this is up to you as a service provider to allow your customers if they should be capable of creating very small nodes, like here with 2 gigabytes. And the range of predefined policies is up to 64 gigabytes of memory and according CPUs. But you can define it on your own as well if you want your customers just to deploy Kubernetes clusters of a certain size. Then you have to define the policies. So this is quite cool as well, because here we define the policies visible within the Kubernetes cluster. So these are vSphere storage policies that can be used within the Kubernetes cluster. So if you have done the exercise in Kubernetes of defining a storage class, mounting some storage, creating persistent volumes and persistent volume claims, this is really easy. You define the storage policies available in Kubernetes, and automatically vCloud Director together with TKG, and it doesn't matter if it's TKGS or TKGM, will create the according policies and will prepare everything so that the developer just have to define the storage. So this is a persistent volume claim and just use it in a container. So you will have much less manual work than you will have traditionally. In the next, you define the pod and the service network. So we can leave it as default because it's isolated. So we can use this network several times, and then we can go ahead and create it.
Stefan, just to kind of rewind there, when you had those two tiles, now if I can run TKGS or Tkgm within the same cluster with VCD, what would be the use case for using Tkgs?
Out of Cloud Director, you mean? One possibility would be if your customers, or if you have big customers and they are using a whole vSphere environment, vSphere cluster, then it would be a possibility to use Tkgs because there's no need of separating. And Garrett, you muted yourself.
Yeah, just one additional comment, and that's really temporary, is that there yet, as of today, there's not full feature parity between the Tkgs and Tkgm implementation, right? But this will be fixed like in the really near future. So for some providers which might have already gone down the Tkgs path, they might want to stick to that until the Tkgm implementation has caught up, which will be very, very soon, right?
Yeah.
And it's not that hard to move, because I mentioned yesterday already, it's like moving from Debian to SUSE instead of moving from Linux to Windows. So it's just a provider that will be changed. And I already prepared, so the cluster already running. We can download the kubeconfig, and the only thing you as a developer have to do is to use or to tell Kubernetes that you want to use the config file. So I just specified the kubeconfig, and we can work and interact with the Kubernetes clusters. So as an example, I will just do a get nodes to print out. And if you remember, we created one control plane and one worker node. Yeah. And this is really easy going. And now a developer could let's create a very basic Nginx image container. So Nginx. And here we go. I have to do it the right way. Okay, of course. I just explained, please use the right kubeconfig file. Here we go.
There we go.
Boom. Awesome. Yeah, that's pretty impressive, isn't it? It does make things a lot easier when you got just that single kubeconfig file to point and go. Yeah. Okay, great. And is yeah, I think that's probably about it, isn't it? Is there anything else we need to see?
No. As I mentioned, I can speak for hours, but I have time back. Yeah,
no problem, no problem. Well, we're going to go on to Tkgm next time, and I'm sure we'll explore that in some more detail as well. So, Stefan, thanks for setting up the lab and showing us around there today, and for also walking us through the diagrams that you had set up. And Garrett, thanks for your input as well in terms of looking at the commercialization of it. These are all really interesting and important points. And I hope our providers are finding this useful. Like I said, join us next time for Tkgm. Thanks, guys.
Thanks a lot.
Everyone. Bye.
Thanks. Bye-bye.